now.
Hey, good afternoon, everyone. Thank you for joining. Welcome to part one of Windows Hello for Business. This is a part of the Improving CSP Zero Trust Concepts webinar series. And we're going to be talking about Hello for Business and how that ties into passwordless authentication that we talked about in our prior session. And again, today, Chris Lee will be presenting, and we'll go ahead and hand it off to Chris. Thank you for attending.
Thanks, Jim. As Jim mentioned, this is our second session of our passwordless authentication mini-series. But if you did miss our first session, which was an introduction and a basic overview of what passwordless authentication is, you can go back to our recording of that session. We do have it up on our CSP website here, and the link is shown on the slide. But today we are going to start into Windows Hello for Business. And as you can see, this is going to be a two-part topic. Our first part today, we're going to build upon the concepts that we went over in our last session last week and dive into Windows Hello for Business as a passwordless authentication option. Our second part next week, we'll do a walkthrough of actually setting up Windows Hello for Business in a live environment. So hopefully you can see what it takes to get this up and running and start using it in your own environment. And then finally, we'll wrap up our passwordless authentication mini-series by going into the Microsoft Authenticator app as well as FIDO2 security keys as our other passwordless authentication options. So for today, I first want to talk about Windows Hello versus Windows Hello for Business, because that part for business at the end there makes a big difference. Then I'm going to go into some of the background concepts behind Windows Hello for Business so that we can all have a better understanding of the different paths that we can take towards implementing passwordless authentication in our own environment, specifically around the different paths for Windows Hello for Business. And then finally, and maybe more importantly, I'm going to walk through what all happens underneath the hood when we go through the registration and the actual authentication process using Windows Hello for Business. So I'm going to probably reference some concepts we talked about in our first session last week. That was the basics of passwordless authentication. But if you did miss that, and if you're unfamiliar with any of the terminology or the details, please use the Q&A on the side of the screen there, as I do have several others from our Improving CSP team here to help answer any questions that may come up. Right, so let's get started with Windows Hello versus Windows Hello for Business. On the outside, these are going to appear to be pretty much the same thing, especially from the end user's perspective. I mean, it's going to be the same experience when they use them to log in. Both are hardware-based security processors, or you use a hardware-based security processor such as a TPM chip that is physically built into the Windows device to store sensitive information. But for Windows Hello, this stores a cached username and password that is used to log on locally to the device itself. But let me say that again, because that's a very important statement. For Windows Hello, this is using a cached username and password, and that logs into the local device itself. You can set this up to use fingerprint readers or infrared cameras, so you can do facial recognition on that computer, but you're logging in to the local account. You're not logging in against a domain account. You're not logging in against an Azure AD account in Microsoft 365, or even any of the Microsoft consumer-based services like Outlook.com. On the other side, Windows Hello for Business does not store any username or password into TPM, but rather it uses asymmetric cryptographic keys that can be used to log into a domain account or an Azure AD account, an external identity provider outside of the machine itself. So in this case, you're not just logging into the local device, you are logging into the domain against the domain controller, you're logging into Azure AD in the cloud, and therefore you're able to access services that are located in those environments, whether it's another on-premises application or another SaaS app up in the cloud. But because our series is focusing on Microsoft Cloud, I'm going to focus on Windows Hello for Business, because that really falls along with also the true passwordless authentication. When we first start looking at deploying Windows Hello for Business, there's 3 different deployment models that we can consider. The first is cloud only, and this assumes that you don't have any resources on premises. Everything is in the cloud. You're not authenticating to anything on-prem. There's no Active Directory. There's no on-prem applications or network services like a network proxy that tie into any kind of centralized directory authentication. This is the most simple of models to deploy, because pretty much everything's already built for you. It's all up there in Azure. It's there. But you have to be a cloud-only presence. You're not logging into the cloud or anything on premises. You're just logging into the cloud. On the other side of the spectrum, we have the on-premises deployment, and this is where we would have no cloud services, but we would have a lot of on-premises cloud or on-premises apps and services that we need to authenticate to. So the on-premises deployment model is going to be very similar to the architecture of like a smart card authentication. On this side of the spectrum, we do have things that we have to deploy to support Windows Hello for Business, and specifically, this includes an internal PKI or a public key infrastructure or an enterprise PKI. You might hear me say those terms, but I pretty much use them synonymously there. Now I also have, I have listed Active Directory Certificate Services, or ADCS, and this is the Microsoft implementation or solution for a PKI, but you technically could use any third-party enterprise PKI solution as well, so it doesn't have to be the Microsoft PKI. I also have Active Directory Federation Services listed, or ADFS for short, as another requirement for on-premises. Now, most of us don't live in one of these extremes. We're not just cloud, we're not just on-prem, but rather we live somewhere in the middle. We have both cloud services and both on-premises services that we want to authenticate to. So this is where our hybrid model comes in the middle here. Certificate services are still a requirement here, as it acts as a common trust between all the different moving parts and components that make up Windows Hello for Business. I also still have ADFS listed underneath hybrid, but it's not actually a requirement in a hybrid deployment. So if you already have ADFS deployed and you're using it, great, you can leverage it with Windows Hello for Business. But if you don't go out and deploy it just for Windows Hello for Business, because you don't actually need it. It just adds another layer of complexity that is really, I don't think you would need. The last requirement I do have listed is for directory synchronization services, and that's through Azure AD Connect or AADC. This is going to be a requirement, and we'll see here why that is in a little bit as we walk through some of the processes that happen underneath the hood for Windows Hello for Business. But as hybrid is the most likely scenario for most of us, I'm going to focus on hybrid moving forward throughout the rest of the presentation. Oops, sorry, I thought I double clicked. So in a hybrid deployment, we also have to think about how do we establish trust. And there are technically three options, but we can only really use two at this time. The trust mode defines how Windows Hello for Business authenticates to the on-premises Active Directory. Both key trust and certificate trust require an enterprise PKI to act as that trust anchor for all the resources involved. But how the PKI is used differs a lot between the two different modes. For key trust, certificates are, they're really only used within Active Directory for domain controllers to validate their identities. Under the key trust model, certificates from the enterprise PKI are just issued to the domain controllers, but that's it. If you did have ADFS floating around in the environment, you could use it as part of a key trust model or mode, but key trust can also operate without ADFS, so it's not a requirement. On the other side, we do have certificate trust. And with this mode, certificates from the enterprise PKI are issued to individual users. Therefore, it has a much higher impact and more dependency on a properly scaled out PKI deployment. Certificate trust does require ADFS. So that is a hard requirement when we are using certificate trust. So this also adds a higher level of complexity required to operate in this trust mode. And in this case, ADFS, it acts as the certificate registration authority against the PKI. This also means that authentication to Azure AD is also federated through ADFS. So again, more complexity. There is a third mode in the middle here called Cloud Trust. And this is an attempt to make all of these complexities, the requirement of an enterprise PKI, ADFS, all that stuff, trying to eliminate all of those requirements. It's a means to try to make this as simple as possible. But unfortunately, this deployment model is only in preview right now. So it's not generally available yet to use, at least not yet. So before we dive into the inner workings of how Windows Hello for Business works, let me first break it down into three major phases. The first phase, we focus on device registration. If you recall back to our previous session, we discussed how a passwordless credential is tied to the hardware in which it's registered. So for a security key, this is kind of an easy concept to grasp because it's an external physical key. This you can plug it in and remove it from a computer. The credential lives and was created on that key. But for Windows Hello for Business, the computer is the hardware that's running Windows, but it's also the device that stores the passwordless credential. So we need a way to tie the credential to the device, and that's where the device registration plays a pretty important role. The second phase is provisioning out the Windows Hello for Business credential to the device. This is where we link the credential inside the security processor or the TPM chip so that the credential is bound to that device. And then once the credential has been provisioned, the last phase is using it to authenticate. But remember, in hybrid, we're not just authenticating to Azure AD, but we're also authenticating to on-premises Active Directory. So that means the Windows Hello for Business credential can hopefully be the only credential that we need, and everything else just kind of takes advantage of single sign-on capabilities. Okay, so let's get started on the device registration process. Remember that this phase is to make the device known so that it's trusted, and therefore the Windows Hello for Business credential is also trusted. In a hybrid deployment, this means we need to focus on hybrid Azure AD join, which means the device is trusted by both the on-premises Active Directory as well as Azure AD. If ADFS is in place and federated authentication is being used, this process is going to be a little bit different than what I'll go over here, but the end result is essentially the same. But for simplicity, we're going to assume that we're working in a managed domain, meaning we don't have ADFS in place. For hybrid Azure AD join, the process starts with a user authentication against the on-premises Active Directory domain. This could be for an existing Windows device that's already joined to the domain, or a new device that's being set up, kind of like through the Windows out-of-box experience when you're doing a first setup of Windows. So it could be an existing or a new machine. Most likely, this is going to be a username and password. But if you have smart card authentication set up for your on-prem AD, then you can use that instead. Either way, we just need to authenticate to the on-premises domain. After Windows Hello for Business is set up on the device, then future authentication will be able to leverage passwordless for both on-prem and Azure AD. And one thing to note is that this process may start with a username and password, as that is probably what is set up for on-prem AD, but authentication to Azure AD would not require the use of a password. So one of the things I do want to kind of stress here, because we are talking about passwordless authentication, and here I'm saying you have to provide a username and password. This is because this is how we authenticate to on-prem AD today. If you had smart card authentication set up to where you're not using a password but you're using a smart card, you could use that to start this process as well. But the reality is most of us are logging into our domain joined computers today, or logging into the domain using a username and password. So as I mentioned, even though this process starts with a user login, the remainder of the rest of the join process is going to run underneath the computer context, not the user. So when a user logs into the device, this triggers a join task that is built into Windows. And this task performs an LDAP query against the on-premises domain to find what's called a service connection point record, or an SCP. And this record just contains some information on how to locate the device registration service. The setup of the SCP is part of enabling hybrid Azure AD join for devices through the Azure AD Connect, or just the synchronization services on Azure AD Connect. So if you go through the wizard to reconfigure your AADC server to start doing hybrid Azure AD join devices, there will be a checkbox to enable that feature. All that really does is call a script that creates the SCP record in Active Directory for us, but we could always manually create it as well. But I will point out it's very important to realize that once the SCP exists, regardless of how we created it, current builds of Windows 10 and 11, and even Windows Server 2016 and up, they're automatically going to start using the SCP. So therefore, if you're trying to scope or pilot out your hybrid Azure AD join to not affect all of the devices in your environment, there's some additional steps that you have to take that are a little bit out of the scope of our discussion, but it restricts or scopes down the impact of the SCP to just the devices you want. So technically it's telling all the devices that you don't want to be impacted by the SCP to not run that task. But just kind of a mental note that there's an additional couple steps there to take if you're trying to scope out your hybrid join. So in our case, again, we're not using a federated domain, so we don't have ADFS, but rather we're just using a managed domain. So when Windows reaches out and it gets the SCP, it's going to realize, or it's going to be told back, that this is a managed domain being used. So what it does is Windows is going to create a self-signed certificate that will be used to initially identify itself with Azure AD. This self-signed certificate approach is only used when we're in a managed domain environment. If we were federated, it would authenticate. The Windows could actually just authenticate itself against Active Directory via ADFS, which is trusted by Azure AD. Therefore, we don't have to go through this process. But just note that when we're using a managed domain, the SCP gets returned, and Windows then creates a self-signed certificate. The self-signed certificate is not trusted by anyone because it is self-signed. But because the computer is a member of the domain, that establishes a trust between Active Directory and Windows. So what Windows can do is it writes back the public key of its certificate back to its Active Directory computer object, specifically into an attribute on the computer object called user certificate. After this happens, we need to wait for Azure AD Connect to synchronize the change for the device object from the on-prem AD up to the Azure Device Registration Service, or Azure DRS. If this is the first time the device is being synchronized, if this is like an out-of-box setup, that it's not an existing device, so it might be the first time this device is being synchronized. There's going to be some other key attributes that get sent up as well, and this includes like the object GUID and the object SID. But if this is an existing device that's already been synchronized in the past, all this does is really just update that existing object in Azure AD to include the new attribute value for the user certificate. So this makes Azure AD aware of the self-signed certificate value that was generated by Windows a few steps earlier. Because Azure AD trusts what Azure AD Connect synchronizes, it will then trust that this self-signed certificate belongs to our computer because it's coming from a trusted source, which is Active Directory. At this stage, if you looked at the Azure AD portal, the device object will show up, but it's not fully joined yet. So it will show up and its status will be pending. And this is just pretty much to let you be aware that the process has started. So this can be helpful if you do run into problems with the join process. You can look at the device state in the Azure AD portal and you can see, did it ever get past the pending state? If it reached pending, we're at least at this stage. If it got past pending, then we'll be in further stages. So it's really just kind of to help you out if you needed to troubleshoot the process. So back on the Windows device, the join task is going to continue to run to check to see if that certificate value has been synchronized, right? So this AD Connect the synchronization surface typically runs every 30 minutes, so it might not be up there immediately. So that's why this join task is just going to kind of repeatedly check. The task runs every time someone logs into Windows, but it also runs every hour after log on. So even if the user logs in and stays logged in, within an hour, the task will run again to check to see if that certificate has been synchronized up. Again, the default synchronization schedule is 30 minutes. So unless you have really complex Active Directory replication that causes delays, you should see that certificate value being synchronized up within the hour. Once the join task detects that the Azure AD computer object has been updated, Windows is going to try to authenticate itself against Azure AD by using the private key of that self-signed certificate. Azure AD is going to trust that certificate because it's aware of the public key that was synchronized up, so it can validate the digital signature on the authentication request. Now, this is all possible because Azure AD does trust what is synchronized up from the on-prem AD through Azure AD Connect. And since the public key of the certificate was synchronized up, and that key can also validate the digital signature on the request, it's going to trust that the authentication request is coming from that Windows domain joined computer. So in response, Azure AD is going to generate an ID token. Now, this isn't an authentication token, it's an ID token, which is just representing the ID of the computer object. And then it sends this ID token back to the Windows device. That's important to kind of point out that that difference here. It's not an authentication token, it's an ID token. We'll see why here in a second. The self-signed certificate may have been used to initially establish some degree of trust between Windows and Azure AD, but it's not able to authenticate the device against Azure AD. So the next step for Windows is to create two key pairs, a device key pair and a transport key pair. Both of these key pairs live and are secured within the security processor or the TPM chip on that Windows computer. Because the self-signed certificate couldn't be used for authentication, Windows then creates a certificate sign-in request, or a CSR, so that it can request a device certificate from Azure. The device key pair, the private key of the device key pair is then used to sign the CSR and the ID token that was given to it from Azure AD. And then Windows sends those both back up to Azure AD, or the Azure Device Registration Service, but also includes the public key along with that. So it uses the private key to sign the CSR and the ID token and sends that with the public key up to Azure. The Device Registration Service uses the provided public key to validate the digital signature on both the returned ID token and the CSR, and it trusts that the device's key pair, or it trusts the device's key pair, because it can validate the ID token that was signed and returned to it is the same token that it generated and sent to Windows a couple steps before. So it's pretty much saying, hey, yeah, this is the same token that I issued you, but you're returning it to me with a signature using your private key, and I can decrypt that using the public key that you've provided. So I'm going to trust that private key and public key pair, right? This tells pretty much Azure that the device's signature is coming from the same device that started this entire process. And then what Azure AD is going to do is it's going to respond back. It's going to take that CSR, it's going to generate a certificate, a device certificate, and send that back to Windows. It's also going to write back a globally unique device ID value back to the Azure AD device object. But the key part here is that we're receiving a Azure issued certificate that can be used by the device to validate the device's identity in the future. So when Windows receives that certificate from Azure, it's going to add it to its local machine certificate store so that it can be used for those future authentication attempts against Azure AD. And at this point, the device has now completed the hybrid Azure AD join process. But if you look at the Azure portal, it may not reflect that yet. And that pretty much is because we may have to wait for a sync cycle or two to run on the on-premises environment from Azure AD Connect to replicate up, hey, the Windows device has received a certificate, and then it will mark it as fully hybrid joined up in the cloud. But one thing I do want to reiterate here is that all of this that we talked about, other than the initial user login against the domain, all of this happens underneath the device context. So if you have a network proxy in place that requires user authentication, it's most likely going to stop Windows from talking to Azure on its own and is going to break this process. So you may have to make some exclusions or additional rules to allow Windows as a computer context to talk through your proxy solution. Okay, so now we talked about the device registration process. The device is registered. The next step is to provision out a Windows Hello for Business credential for a user to that device. So the provisioning process is going to be dependent on both the deployment model as well as the trust type being used. Both key trust and cert trust rely on private and public key pairs, but under key trust, you'll see we're going to have another self-signed certificate to kind of start off the process. But under a certificate trust, that doesn't happen because we can just get a certificate from the commonly trusted enterprise PKI instead. So let's jump into how provisioning works. When Windows starts the enrollment process, it first reaches out to the device registration service again in Azure. In this example, it is a managed domain, so there's no ADFS in place. But if we were using federated authentication with ADFS, Windows would reach out to ADFS instead as ADFS acts as the device registration service. But when Windows reaches out, it's going to send the user credentials to Azure AD. So this could be a username and password, but it could also be an existing strong credential, such as one that was already registered on an external FIDO2 security key. So if you already went through the process to get a passwordless credential, you could use that FIDO2 security key to kick off this process to get a Windows Hello for Business credential for your Windows device. There's also something called an Azure Temporary Access Pass. It's currently in preview, but the intent of this is an admin can generate a time-limited, one-time use passcode that is used by the user to start a passwordless registration instead of having an account password. But either way, we're starting this process by sending an Azure AD credential that we want to have provisioned onto Windows as a Windows Hello for Business credential. We're passing that up to Azure AD. Assuming the case where the credential was only a username and password to get started, Azure AD is not going to issue a strong credential like a passwordless credential just because we've provided a weak credential. Remember, username and passwords, our previous session, we pretty much talked about how passwords are pretty much useless and imply no security whatsoever. So Azure AD is not just going to trust, hey, a username and password has been provided, so I'll let you register a passwordless credential. Instead, Azure AD is going to make sure that the authenticating user is using a stronger credential, meaning that it's going to redirect back to MFA. So even if the user has already completed an MFA challenge, logging into a browser or whatnot on the machine, earlier when they first logged into computer, MFA is most likely going to be prompted again. And this is because in this process of provisioning a passwordless credential, Azure AD requires that the MFA challenge has been completed within the last 10 minutes. And this is just an extra security measure that Azure AD has in place because of the power a passwordless credential could have. So it really wants to make sure that the current user authentication session is valid and is using MFA. So for our managed domain environment, this is going to be Azure MFA. But if you did have a federated environment where ADFS is used, this could be any third-party MFA provider that's integrated into ADFS. So after the MFA challenge is completed, the claim is added to the token and sent back to Azure AD. If everything was successful, then Azure is going to issue an Azure DRS access token. And one thing I'll point out is that if we did use a strong credential, right, if instead of passing a username and password, if we did have a FIDO2 security key that we were using to initiate the user authentication, then all of these MFA steps are actually skipped because they're not necessary. Another strong authentication method is being provided to start this process. So Azure is going to then send this access token back to Windows to be used to generate the Windows Hello for Business credential. When Windows receives the access token, it's going to start off by setting up the TPM to store the passwordless credential. And the first step is to set up some form of means to unlock the TPM or the security processor, the data that's stored in there. And this is often initially a PIN. This could be another form of what's referred to as a gesture, such as a biometric input like a fingerprint or a facial scan. But a gesture is simply just a type of input used to unlock the TPM. And technically, a PIN is considered a gesture too. Windows is always going to ask for a PIN to be set up, even if you want to use a fingerprint or your infrared camera for facial recognition. And this is because the PIN acts as a fallback in the case that either your biometric hardware, the sensor hardware is not working correctly, or for some reason you can't complete your biometric gesture. For an example, for me, something that I struggle with, especially during the winter months, is my hands get very dry, and I might have like cracked skin on my fingers. So when I go to touch my fingerprint sensor, it doesn't always recognize my fingerprint. And in that case, having my PIN as a fallback is a good thing so that I'm not locked out of my computer. If you're like many others, your initial reaction might be questioning, okay, hey, the use of a PIN, wouldn't that seem to be less secure than a password? Isn't a PIN just 4 or 6 numbers? So how can that possibly be more secure than a password? And this is a very common concern to have. But the key difference is understanding how a PIN and a password are used. In the case of a PIN, that PIN is tied to the device it was set up on. It's never transmitted or communicated outside of the device because it's only used to unlock the local TPM. A password, on the other hand, is used to log into something else, a remote service or another identity provider external of the machine. So it's authenticating against something other than just the local device. Therefore, to be able to use the PIN, you have to have physical possession of the device as well, which makes it a lot stronger than just having a pass or how a password is used today that is communicated. But once the PIN is set up, Windows generates a new key pair in the TPM to represent the user. This key pair is just like how the device key pairs were set up. But this key pair is generated only after the PIN is created. But you're probably going to get prompted if you have biometric scanning hardware in your computer, you're probably going to get prompted to set up your fingerprint or your facial scan based on that hardware. But even if you always use biometrics, so if you set up Windows Hello for Business and you enter your PIN and you set up a facial recognition, most likely you're always going to use your facial recognition as your gesture to unlock your Windows Hello for Business credential. But just remember that the PIN is just always there as that fallback option.
Hey, Chris, there was a question in the Q&A, and the question was, can you use the same PIN on every device?
Yeah. So yes, you can use the same PIN. Nothing stops you from using the same PIN across multiple devices, as those devices are not aware of each other. So technically, that PIN, when you use a PIN, if it's 1, 2, 3, 4, that's tied to the device in which the PIN was created. And it should only be used to unlock the security processor, the TPM chip. But that doesn't stop me from using 1, 2, 3, 4 on my second Windows computer. And when I do that, my PIN starts acting more like a password. It's not being transmitted anywhere, but it's less secure because it's the same for multiple devices. But kind of think of it this way. If you have 2 checking accounts with ATM cards, nothing stops you from using the same PIN on each ATM card. And that's the same case for Windows. Just because you can use the same PIN doesn't necessarily mean you should, right? So this really becomes more of a user education challenge than it is a technical challenge. But yes, you can use the same PIN across multiple devices. They're just unaware of each other having the same PIN. Okay. So the next step will be for Windows to return the access token to the Azure Device Registration Service along with the new user's key pair or the public key with some device identifying information as well. The assumption is that all of this has been done so far within 10 minutes. So registering your PIN, registering your fingerprint, registering your facial scan. All of this has been done within 10 minutes. Otherwise, that MFA claim for your original user credential will have expired, and then we're going to have to start this whole process over again. But Azure AD is going to take the user public key, and it's going to write it to the user's object in Azure AD, specifically to the attribute MSDS-key credential link. With the Azure AD user object having this value associated to that attribute, this links the key pair to be used as a credential for the user. The device info is also used to link this credential to that specific device it was generated on. So remember, the concept of a passwordless credential is that it is tied directly to a specific device, the one that created the initial key pair. The TPM on the computer ensures that the private keys are safe and they never leave the device, but associating that public key to the device in Azure AD also acts as another layer of security, ensuring that the credential can only be used from that expected device. Azure AD is then going to create a key ID for the associated credential and send it back to the key registration service, who is really just going to forward that back onto Windows. It kind of just passes right through. By receiving the key ID from Azure AD, Windows then knows Azure has accepted the key credential, the public key. It has added it to the user's object in Azure AD. And so Windows says, hey, I'm going to mark the provisioning process complete. And this is technically the last step for Windows, but there's one more thing that has to happen before that key can be used for authentication. And right now, that key is only aware to Azure AD. So what we need to do is make the on-premises Active Directory aware of it. And this is done through Directory Connect, Directory Synchronization Services, and that's Azure AD Connect. And what that's going to do is it's going to pull the change from Azure AD. It's going to see that MSDS credential link attribute value updated in Azure AD. And it's simply going to pull that back down and update it on the Active Directory user object on premises. So should this have been a federated environment, there would have been some fewer steps here to complete as certificates are used instead of keys, but this would end or wrap up the credential provisioning process. So at this point, Windows has a user passwordless credential, a Windows Hello for Business credential registered on the device. Azure AD is aware of it. On-premises Active Directory is aware of it. So then we can start looking at how do we use it to authenticate. If you've ever used Windows Hello for Business before, I think you're probably going to be amazed with how much actually happens underneath the hood to make this work. Because from a user perspective, I just sit in front of my computer, it scans my face, and I'm logged in. So let's walk through the process of authentication with a passwordless credential or Windows Hello for Business credential. And the first step is to start in the authentication process by dismissing the lock screen on Windows. So if you were the last person to log into Windows, great. Your account's going to pop up, your picture will be there. Otherwise, you're just going to have to select your account if you've logged in before or type in your username so Windows knows who's trying to log in the machine. And this is important because we need Windows to know if your account or if a passwordless credential or Windows Hello for Business credential is available for your account. It will know if one has been registered. So if it has been, you'll see here, and I have it on, might be a little hard to see the image down here, but you pull up your account, it's going to show you credential providers to use to log in. And you can see the one that's highlighted here is a little eyeball that represents the facial recognition. There's a fingerprint scan. There's a little digit keypad here if you wanted to use your PIN. But we need to select a passwordless or Windows Hello credential option to start the passwordless authentication process. So the options shown here on the screen are going to be dependent on what hardware is in your computer. If you don't have an infrared camera, you're not going to see the little eyeball for a facial scan. But it also depends on what you've registered with your account. If you didn't register a facial scan, then you're not going to see the little eyeball there either. So assuming that you select one of the Windows Hello providers from the logon screen, you're going to be prompted for that gesture. So the facial scan, the fingerprint scan, or your PIN, and assuming that you've successfully put those in, Windows is going to first unlock the credentials stored in the TPM. Since we're using key trust in our example, this is our user key pair credential that we just generated in the previous provisioning process. But if we were using certificate trust, we would simply be unlocking the TPM to unlock our certificate credential. But either way, Windows is simply unlocking the credential into what is formally called a packaged credential ticket, but it's just credential information. Next, Windows Hello is going to send this credential ticket to the Win Logon service. And that's just a service that runs within Windows. If you're not familiar with it, the Win Logon service is responsible for loading the user profile in the desktop once authentication has been successfully completed. But note that the PIN and the gesture data is not included in this credential ticket. That is only required to unlock the security processor or the TPM chip. So that gesture data is never sent or packaged anywhere. It stays with the TPM. The Win Logon service is then going to forward that credential ticket or credential package to the local security authority or the LSA, which is pretty much going to identify what the appropriate authentication providers that should be used. In our case, since we're using a hybrid deployment and the computer is a domain joined member, the local security authority is going to determine that, hey, we need to authenticate against Active Directory. So the Kerberos provider is what we need to use. So then the LSA simply forwards on the credential package again up to the Kerberos provider. But note the dotted box surrounding these components. This box represents the local device. So everything that's happened right now has occurred within that local device only, hasn't left that device. So the Kerberos provider uses a domain hint from the credential ticket, and then it generates some pre-authentication data that's going to be used to authenticate against Active Directory. This pre-authentication data is then signed using the Windows Hello for Business credentials private key, and then packaged along with the credentials public key into a message that's called the ASREC message. And this is just a formal name for this packaged message that is unique to the Kerberos process or Kerberos protocol. The public key is included in this packaged message, but it's included in the form of a certificate when it's added into the message. It's important to note that the data is only signed by the private key, and that the private key itself is not being packaged or sent anywhere as part of the process. It's staying on the local machine itself. The Kerberos provider is then going to send this ASREC message to the identified domain controller in the on-premises domain. And once it's received by a domain controller, it's going to digest this message and extract the public key certificate, which is pretty much determined to be self-signed because it's just it was generated on the Windows device itself. But in this case, Active Directory is going to extract that public key from the certificate, but it also knows that to be used, it should have been registered with that user's AD object as well within the on-premises Active Directory. So the domain controller is going to use that pre-authentication data, which will contain the user's UPN, to look up the user object that matches that UPN, and it's going to try to match the public key provided in that certificate to the public key value that was registered back on that MSDS key credential link attribute on the Active Directory user object itself. So it's going to try to match those two to validate that it's the same key. This tells, when it is the same, this tells Active Directory that it can trust that public key, and then it uses that public key to validate the signature on the Kerberos pre-authentication data that was sent up. So that in turn tells Active Directory that it can trust the credentials that are being provided as part of that pre-authentication data. This ability for Active Directory to process the keys in this way, it was a feature that was first introduced in Windows Server 2016. So if you are using Windows Hello for Business and you are using the key trust mode or model, then you have to have domain controllers that are running Windows Server 2016 or above. But if you were using certificate trust, the LSA would just send the certificate, the user certificate, instead of the keys. And that certificate was issued by the enterprise PKI. and Active Directory could process a user certificate, and that capability was introduced well before Windows Server 2016. So in a certificate trust model, there's no dependency on Windows Server 2016, but in key trust, you have to have domain controllers running Windows Server 2016 or above. The domain controller performing this validation acts as the Key Distribution Center Service, or the KDC. After validating the request, it's going to issue a ticket granted ticket, or a TGT, that can be used for all future authentication requests against the domain controller. So this TGT gets sent back to the Kerberos provider on the Windows device as a AS rep message, again, just a formal name for the response, but is signed by the domain controllers, or the KDC's certificate. This is where having that enterprise PKI is a requirement even for key trust, because it's necessary for the KDC's response to be signed by a certificate that's trusted both by the KDC and Windows at the same time. The Kerberos provider is going to validate the KDC's response by validating the signature of the KDC certificate that signed that response. So this is pretty much done by validating that the certificate's subject name or subject alternative name values include the same DNS name as the domain that Windows is trying to authenticate against. The Kerberos provider is then just going to pass the validated TGT down to the local security authority, which just caches that ticket for future authentication use. This enables Windows to authenticate to additional on-premises resources through Active Directory using this TGT, or this ticket granted ticket, versus having to go through the entire authentication process again, starting with the whole Windows Hello gestures. So, this should result in the user experiencing a kind of a single sign-on experience for anything that is Active Directory related, because Windows will be able to pass on this TGT automatically for authentication to other Active Directory resources. And the last step for the Active Directory portion of the authentication flow is that the LSA notifies the WinLogon service that authentication was successful against the domain. This is going to trigger the WinLogon service to start loading the user's profile and the desktop, which is pretty much the only part of the logon process that is visible to the end user. But right now we've logged onto Active Directory, but now we also have to log into Azure Active Directory. So that's the second part of this authentication flow. So while Windows is loading the user's profile and the desktop, the local security authority is passing along the Windows Hello for Business credential ticket to another credential provider known as the Cloud Authentication Security Support Provider, which is a mouthful, but we just call it the Cloud AP for short. And this Cloud AP is purpose-built specifically to know how to authenticate against Azure Active Directory, but it is a component that's built into Windows itself, so it lives within the local device. So again, this Cloud AP is purpose-driven to know how to authenticate against Azure AD directly. So the first thing it's going to do is it's going to send a request up to Azure AD and ask for a nonce. If you recall from our last session, a nonce is simply an arbitrary, randomly generated value that's used to uniquely identify this unique authentication request versus, trying to be malicious and try to replay other authentication requests to trick Azure AD into providing an authentication token. So this nonce, again, is just an arbitrary, randomly generated value that's associated to this specific authentication attempt. Azure AD is going to generate this nonce object, and is simply just going to send it back to the Cloud AP provider. The Cloud AP then uses the Windows Hello for Business user's private key to sign the nonce. Very similar to what we've seen in the previous steps, right? We're just using the private key to sign this nonce. And then the Cloud AP is going to return the signed nonce up to Azure AD, who's going to then try to validate the signature. Again, the private key never leaves the Windows device itself, right? It's only used to sign this nonce, but it never leaves the device. So validating this signature in Azure AD, Azure AD does this by using the public key that's associated to the credential and is saved to the MSDS credential or key credential link attribute on the Azure AD object, just like how on-premises Active Directory validated the signature because it knows what the public key should be. So once the signature is validated, Azure AD confirms that the nonce value matches the value that it just generated for this authentication attempt. And that's simply, again, just to make sure this isn't some kind of a forged authentication attempt or anything like that. So it's just validating that it's the same authentication that's being attempted. So once that nonce signature is validated, Azure AD is going to generate a primary refresh token along with a session key. Remember that Windows Hello for Business contains device info for the registered device that generated the credential. That credential is tied to the device it was created on. But also remember that during the device registration process, the device sent up a device key, but it also sent up a transport key. It created two key pairs, right? The device key and the transport key. So it also sent up its transport public key. Azure AD uses the device info to look up the registered device object in the cloud directory, and it retrieves that device's public transport key. It then uses that transport key, it takes the PRT and that session key, and it encrypts those to that device's public transport key. So this is how we're tying in the device back to the user authentication. And then Azure AD just sends the encrypted PRT and session key back to the cloud AP. And because the device's transport key was generated by the same device being used to authenticate, the cloud AP can retrieve the device's transport private key from the TPM, and it then uses that to decrypt the PRT and the session key. Once decrypted, the session key, which is used to secure the active authenticated session to Azure AD, is then imported into the imported and protected into the TPM.
Sorry, could you say?
Oops, that's my watch for some reason talking. And then the primary refresh token is sent by the cloud AP to the local security authority to be cached, just like the ticket Grandin ticket from the Kerberos authentication. So this enables, again, future authentication attempts to cloud services to be completed without this whole authentication flow again. That's what that cached primary refresh token is good for, and that's what that cached ticket Grandin ticket from Active Directory is used for. So hopefully now the user has both of those tickets in their LSA, and then they can single sign on essentially to any on-premises or any other cloud services. So I know I did a lot of talk in there, a lot of technical details, but that wraps up how the authentication flows, and all of that happens hopefully before the Windows desktop or the profile is actually loaded for the user. So just to recap the Windows Hello for Business process, it consists of 3 phases. The first being device registration, and we saw why this was important because of the last few steps here in the authentication process, because the device has to be trusted and known both the on-prem and Azure AD. After the device is registered, we need to provision a Windows Hello for Business credential to that device, which builds upon that device trust that we established. And then finally, we can use that provisioned credential to authenticate to both on-prem and Azure AD resources. This is kind of where we saw all those pieces come together, especially when we tied the user credential back to the device transport key at the very end there. That wraps up our session. I know we're pretty much out of time, but just as a reminder, we do have part 2 of our Windows Hello for Business topic coming up next week, next Thursday on May 5th at 1 p.m. Eastern. We're going to take the concepts that we just talked about and put them into practice by walking through the configuration and the deployment of Windows Hello for Business in a live environment. So kind of pulls everything together and actually will show you how all of this stuff works in the real world scenario. But with that wraps up our presentation. I don't know if there's any questions in the Q&A that weren't addressed. I'm just going to do a quick look.
There's not. I've been watching.
Okay. All right, great. Well, I appreciate everyone's time, and let me just go back here so we have our schedule up. Appreciate everyone's time for joining into our session today. This session has been recorded and it will be posted up onto our website, shown here at the bottom right with our cloud solution provider page underneath the Improving website. So you can review all of our recorded sessions, but if you would like to register for future sessions, you can use our QR code here on the left to scan and go to our registration page. So we do have upcoming sessions or a series planned. We don't have dates for those yet, but once we do, we'll make sure to notify everyone so that you can register for our identity and device access series as well. So with that, again, I appreciate everyone's time and hope you got something valuable out of this presentation. Thank you.
Thank you.